My name is Max Rohr. I'm going to be hosting today. We're filling in for Bob Rohr, who is stuck somewhere in New York City traffic. So we're going to take over the hosting duties. Cody and I will keep an eye on questions and go through a couple housekeeping slides at the beginning of the presentation, and then we'll turn it over to our guest host here. So Ed, if you want to go ahead and start moving through the slides, I'll cover those. Okay. If you're having trouble with the audio, Ed, maybe just move the mouse rapidly over the screen. Look at one of those things. You probably can't hear us, but there's the number, or log out and log back in if you're having issues. And that's GoToWebinar support. Then go ahead and move on to the next one. Okay, if you want a certificate of attendance at the end of the webinar, you can click yes there, and we'll send one of those to you. And you can report that wherever they may take those credits. We'll send you the nice certificate with the date and the topic and everything there. Okay, so we've been talking about this angle mix valve as an AHR 2021 Innovation Awards winner. As of yesterday, we got some good news that we, for 2022, were named one of 3 finalists for the Sustainable Solutions category, which is a new category. So we'll talk more about that in the future, but we're happy to be back in a kind of top 3 podium finish again with another set of products with that award series for 2022. More details to come. Okay, out now, Hydronics 29. This is something that you can sign up to get a hard copy. This is what the front of it looks like. You can get a standard PDF, or on the next slide, you can go to hydronics.caleffi.com, and we've got kind of a virtual experience with the same information and more. So it links to more videos. It's a little bit more interactive, more content to link to than just the static PDF, but we've got all 3 of those options available. Okay, next month, we're going to have another guest star. So Amruta Kanolkar is from the New Buildings Institute, and she's going to tell us about some policy initiatives that are happening in the general decarbonization world. So a lot of electrification things related to heat pumps and heat pump water heaters. It's going to be a policy training, so it'll be a little bit more of a roadmap of what's ahead from the policy side. And then at the beginning of next year, we're going to cover this topic a little bit more from a technical standpoint with our next Hydronics as well. So this will be a discussion about what's ahead and how you can stay ahead of it and be involved in the conversation if you're interested as we move to a different looking mechanical room of the future. And then that brings us to the topic of the day. So Ed Morris is our guest host all the way from Stafford, England today. So we've got a guest star from across the pond. He's the technical manager at Altechnic. So that's kind of a sister Caleffi organization of ours that's based in the UK. He's a podcast star. He's very talented. He knows open systems that they do over in the UK and water quality really well. So we're happy to have Ed, and take it away.
Thank you very much, Max. Well, what an introduction. I don't really know much more I can say from that. I mean, I almost welled up watching that video, to be honest. I've never seen that video before. It makes
a good one.
For such a great organisation. But I think from me, it's good afternoon to you. It's evening time here. We're just losing our sunlight. So yeah, good afternoon, everybody. And firstly, thank you to Max and the team for giving me the opportunity to share some of our stories, horror stories, good stories. I don't know. We'll work that out as we go along, I think. As to how we deal with systems in the UK, I think it's slightly different. I think there was a quote that went out from a call that we had the other day where I'd said, we have systems in our country that I believe are older than your actual country itself. So those are some of the battles that we have to contend with over here in the UK. We do have old systems. We don't always necessarily have well-designed systems. So we're going to try and look at some of that, as we go through the presentation. So if you do have any questions, I'm happy to take some. Maybe at the end, or if Max or Cody feel that there's some that come along, we can sort of interject and have a bit of audience participation as well. So let's make a start. Removing the rubbish from hydronic systems, poor system quality, and what can those consequences be? It's an important thing. I think it's something certainly in the UK that we are putting a lot more focus on nowadays. I think that some of that is driven from the boiler manufacturers, or certainly manufacturers like ourselves. where our equipment can be affected within the systems that aren't necessarily being kept well or maintained well with poor system quality. So we'll look at the whats and the whys. You know, what we're going to look at, we're going to look at the boiler sludge, what we call boiler sludge, copper shavings within systems and the impacts that that can have, pipe tape, you know, any kind of jointing compounds that we may use, and soldering, again, solderable. So we'll take a look at how these affect them. We'll sort of take it on a journey then through the system, how we can keep it clean and the different ways we can do that. And we'll finish off and we'll try and do a bit of a Q&A. But this dodgy debris really can wreak havoc on sensitive hydronic components. And these result in adverse performance, unwanted noise, and generally poor systems. And we can take a look now at the problems, but I think even more importantly, we can take a look at what some of the solutions are. So we've got some touch points, what we're going to try and look at today. So first of all, we will take a look at what are the different types of system debris, of which there are many. You know, we'll try and cover a broad brush here when it comes to what we're going to focus on. The impact of that, which I think is the most important thing when it comes to these dirty systems. What impact does that have? Why do we do what we do to keep the systems clean? UK systems or open vented systems, it's something that was the only way of doing the system in the UK for many years, but we have different ways now. But we'll have a look at the open vented, the pros and the cons to what that is on having an open vented system. The different types of filtration systems, again, like I said, you know, there's different ways. Everybody has their own way of making a system clean and keeping it clean. So we'll look at what those solutions may be. And we'll look at the importance of flushing systems. We call it power flushing here in the UK, and I think it's pretty much the same across the water with you guys. You know, so we'll take a look at the importance of power flushing, but also the pros and cons that can come along with that. And then we'll try and have a little bit of an open discussion, whether that be between me, myself, and my colleagues across the water, or whether anybody gets involved in just some lessons that we can share. Obviously, you know, we have different experiences within the UK market to what's in the US market. And I'm sure there's a lot of commonality that we can share between us there to drive the industry forward, I think. And we'll focus on the sort of different standards that we work to. We work to a British standard 7593, which is about the care and of water quality. And I know that you guys have got one over, and I think there's a recent addition to that as well, which I think Max may have dropped some slides in a little bit later on, that we can focus on how we try and control system water. So that's going to be a broad brush. I'm not going to keep you all afternoon. I have got to get home at some point, so we'll keep it as long as we can. We'll have some fun along the way. I do apologise for my accents. If you can't understand me, I'm sure we can get some subtitles from somewhere, but I'll try and speak slowly and keep it as interesting as I can.
We'll work on the subtitles for the YouTube recording.
Yeah, you might have to do that. Yeah, and I can double check them to make sure it's okay. And I promise I won't swear as well, so I'll try and keep it as clean as I can. So first of all, we'll take a look at the types of system debris. You know, we touched on the first couple of slides there, but it really is the rubbish that we can't see. You know, we build pipes, systems with copper pipes, with steel pipe, olden days lead pipe. We cannot see inside these systems, so we're always trying to second guess what's going on. And if there's no maintenance, then we really don't know. So we'll make a focus first on what we're going to try and combat within these systems. And the first one we're going to look at, probably the most important one, is the boiler sludge. So what is boiler sludge? So sludge is magnetite, and it's commonly referred to as a sludge. And it's a black substance comprised of dissolved and rusted metal from pipework in your central heating system. And it forms when air and water react with ferrous components. For instance, the water within the system reacts with the steel inside your radiators. Now, I'm guessing a majority of us that have worked as engineers or as installers, that at some point in our life, we've taken a radiator off the wall, or we've taken some form of pipe system apart, and we've seen this black water come out of the system. We get it when we vent the system. So we're taking a vent through a panel radiator, for example. The water that comes out once the air is removed can tend to be a black colour, and that's because it's boiler sludge. It's dirty water, it's untreated water within the system. You know, and it can be as thick as treacle. You know, it can really start to have a negative effect on the system. And we can see here from this cross-sectional picture of pipework, what happens if we don't treat it, if we just leave it to build up. You know, you can see the flow paths and the hydronic restrictions that it's going to put within the system. So it is massively important that we take stock of what this sludge is made of. Like we said, it's magnetite. look at how we're going to start to think about removing magnetite. But it's only one of many things that sits inside a system. In the UK, we don't just have radiators to contend with. We have a lot of old steel pipe systems. We have a lot of old lead pipe systems. So all of this together, you know, these older systems, they take a lot more care and they take a lot more, you know, love to get them to operate as efficiently as we want. And ultimately, we are looking for efficiency as well as life, you know, through the life cycle of the system. Secondly, copper shavings, real big bugbear of mine, is, you know, it's something that's so easily dealt with, but sometimes so easily forgotten. And copper shavings, they're exactly what you think they are. They are the shavings from copper. And there are a few reasons how and why these get into the pipe systems. And these include drilling into the pipe. So for instance, if we were trying to drill a branch into a piece of pipe or similar, you know, we drill in and that copper shaving is going to fall inside. But also, you know, if we cut in pipe and deburr in pipe, it's easy to cut a piece of pipe in situ. Maybe, you know, you think you're doing the right thing by deburring it, but if you don't remove that copper from the pipe, then make your connection, it's going to go inside the system. So it's really important to remember that. Now, whatever the reason may be, it's important that it is all removed. Now, a build-up of copper shavings can cause problems with system performance, as it can with sludge, but also with valves. And this debris can sit on the valve seats and prevent them from operating correctly. Now, we do see this a lot in the UK, and I don't know whether it's very common with you guys across the water in the US, but you know, we get reports of valve seats not closing, especially on safety relief valves. Sometimes, you know, other valves can pass in, and it's because you get this foreign material. In this case, it's a metal shaving that's actually sitting on the face of the valve. You know, these valve seats are very, very sensitive. You know, they're designed to work in a way where they seal under very tight conditions. If we're introducing ferrous material, if we're introducing foreign material into that, the valve isn't going to get opportunity to work properly. So, you know, the copper shavings really do have an effect or an impact on the performance, certainly of the valves and other sensitive parts of the components. You imagine a boiler with some of the sensitive components within there, plates, heat exchangers, etc. This is really going to wreak havoc. So it's very, very, very important that we take these copper shavings out. It's easily done. You know, it's just a case of taking a little bit more time, you know, to treat the system when we're doing some installation. Another one, to the pipe tape or PTFE. When I was growing up as a young installer, I was always told that PTFE stands for plumber's tape for everything. Now, there is a scientific explanation on that. I am not going to attempt to say that. It's too late in the day for me here in the UK. I don't know if Max or Cody, either you two want to attempt in saying that. I'm happy if you don't. We can just refer to it as PTFE either way. I'm certainly not going to tackle what that may say on that screen. But the tape is there. You know, we've all seen it, we've all used it, and it's very popular. It's very popular amongst plumbers, certainly within the UK market. And it's mainly used to wrap around pipe threads and to help them, you know, to prevent them from leaking. Basically, we need some kind of joint so we're not taking a metal on metal joint. And for example, we use them on radiator valves or taps. But PTFE tape also goes in the same as plumber tape or Teflon tape and thread seal tape. And if not applied correctly, excess tape can make its way into the water system and can start to create some blockages. So we can all be a little bit overexcited. I think, you know, we're doing a new install, maybe it's getting late in the day, or, you know, you're over keen to make sure that we don't have a leak. And we can all put 2 or 3 more wraps of tape on there than what may actually be needed. And then that excess tape has to go somewhere. Unfortunately, sometimes that tape can make its way into the pipe system. You know, let's look at the picture on the left-hand side, for instance. We've got a male thread there. If we were to overlap the tape, you know, onto the system side, once you start making that into the joint, that tape's got to go somewhere. As you start making the joint, and it will start to tear internally, it's going to go into the system. This tape is made not to degrade. It's there to keep the joint, you know, the joint good. So it's not going to degrade in the system. It's not just going to dissolve. It's going to go somewhere. It's going to create a blockage. Again, very similar. Compression joints, mainly designed to be a dry joint, so it should get your compression between your pipe, your olive, and your nuts. A lot of people, I'm not saying it's the wrong thing to do, I see it a lot in the UK, a few people will put a few wraps of tape over there. Again, if that was to work loose, it's got somewhere to go. It has to go somewhere in the system. It's going to create a blockage. Again, we've spoken about valve seats, we've spoken about boiler components, all those kind of areas. This is where this stuff can really start to create problems. So it's very important that if we are going to use tape, which we do have to use, that we use in the correct manner, with the correct amount or the recommended amount of tape around the thread. So we're not using excess amounts, and we're not dumping too much into the system, you know, and causing problems. So another type of system debris is that PTFE tape. And fourthly, and last one that we're going to look at is solder. Now, I think the very important thing to remember with solder is that easy does it. I was brought up soldering copper pipe when I was an apprentice many years ago. I know I don't look that old, but it was some time ago now. And the most exciting thing for me was when you cleaned your joint and you'd put your flux on there and you'd heat it up and you'd touch your end of your solder onto the pipe and it would disappear. And you think, oh, fantastic, you know, it's gone. But you weren't ever sure whether you'd created a joint. So again, you'd heat it a bit more and you'd put a little bit more solder in there and it would go again. And all of a sudden you think, where's all this going? Am I actually creating a joint? So the key here is not to feed too much solder into the joint. And it is, as it says there, it's really tempting to melt a few inches of solder into a joint, a little bit of extra insurance against the leakage. But excess solder can puddle inside the pipes and it can restrict water flow, and the small bits can form and that break away and they break loose, and they start to cause damage to faucets, to taps, to, you know, because they can move through at some force. It's like a mini ball bearing moving through the system. And again, you know, like we said, the picture on the left hand side, someone's got a little bit overexcited with the solder. It may look great from the front, but you go down the back and it maybe look like some form of big bird has been sitting on the pipe and maybe, you know, done his business down there, but it all seems to drop down the back of the pipe and we don't see it. And then one of the other big issues that we have is when you get it inside of the pipe. So if we're looking at doing something like a copper T, you know, we're getting a little bit overzealous and it's full inside, and you can see there that's actual cutaway of a piece of pipe. You can see we've got that build up now. That's going to cause restriction in flow. It's going to create turbulent flow, which in its very own nature can have problems in the system. But over time, it's going to corrode away. It's more metal that's going into the system. And then again, you know, we do get these solder balls as well. And you can hear them rattling around the pipe. If you've got a circulating pump that could potentially have some solder balls in there, you'll hear them. They'll start to tink and they'll start to bang around the system. It's going to damage the impeller. It's going to damage valve seats. It's going to wreak havoc. So it's really important that we make sure that if we are going to do soldering, you know, we can get what we call end-feed ones or solder ring fittings now that have got the exact amount of solder that you need. So you just heat it up and that solder is almost pre-soldered into the pipe. I'm sure you guys have it as well. But old school ways, when you've got your roll of solder, it's very easy to get a little bit overexcited. So very important that we do that the right way as well. And it's all this is about preparation. So when we are doing work, when we are looking at putting new systems or adding to systems, all this little bit of care and time and attention now is going to set the system up better for the long run and make sure that it's doing what it needs to do for the long life of the system. So the impact of it, you know, what is the impact of the system debris, and does it matter? Well, I can tell you now after what we've just looked at, absolutely it does. It really does matter. So we'll look at some of the issues that can come around, you know, and the impact it can have for the system debris, the impact. So dirt-related problems, and it goes without saying that the ideal hydronic heating or cooling system would be dirt-free, and the presence of dirt can create or can have serious consequences. Now, these include some of the following. So damage to rotating components in circulators, so especially impellers and bushing faces, as an example of a circulator with a clogged or completely clogged impeller due to the sediment in the system. So, you know, we spoke there about rotating parts. We spoke about that. Pumps that are actually, you know, some of them have magnetic drives in there. If that pump's left stagnant or is not moving for a period of time, it's going to start to attract all the magnetite in the system. We see it in the UK, especially on some of our heat interface units. If they don't let the pump cycle through its 24-hour cycle, it's going to start to seize. It's going to start to create problems. So, you know, damage to circulators is really, really important. Every system's got a circulating pump. It has to have that to get the water around the system. We have to make sure we look after it. Now, reduced heat transfer due to failed services in heat emitters, heat exchangers and heat sources, especially those using compact heat exchangers. You know, the modern design of heat exchangers got very small flow paths to increase efficiency and to make them work as best they can. But if we start putting bits of tape down there and putting bits of solder down there and everything else that comes with the system, we're going to start creating problems. And similar failing damage to heat transfer services within chillers. Again, you know, these are very sensitive areas of the system. So it's very, very important that we make sure we give it the best life it's can, or the best opportunity to have a, you know, a carefree life. Erosion of internal pipe surfaces, especially in copper tubing. Copper itself is a very soft very soft metal. If we are putting things like solder balls, etc., around there, we're going to create problems. I think there's a picture in a few slides time that shows the impact how it can start to corrode on the pipework. And discoloration of transparent wetted surfaces, such as those in sight glasses and flow meters. So maybe more on a commercial system or a larger size system, where there may be some external sight glasses to show for flow meters or so what's going on inside the system. If we've got dirty water going through those, it's going to absorb it, it's going to have problems. And again, there's an image a little bit further through this that shows that. An erosion and or clogging of relief valves, balancing valves, check valves, venting valves, and thermostatic radiator valves. All these valves are very sensitive to how the system works. Safety relief valves or relief valves, one of the biggest bugbears for me in the UK is phone calls that we get from engineers to say, we've got a faulty safety relief valve. And I say, well, okay, well, what makes you think it's faulty? It's passing water. If it's passing water, it's doing its job. It's passing water for a reason. Now, they've carried out all of their checks. The expansion vessel is okay and the system pressure is okay, but it's still passing. I can guarantee you that 99 times out of 100, there is debris sitting on the seat and it hasn't allowed the valve to close back down. Even if they've gone in and done their annual check, they're 12 months and they've just checked its operation, I can guarantee you something has passed through that system to keep it open. Same with balancing valves, check valves. Again, people say I've got check valves that are passing. Again, 9 times out of 10, we look inside there, we can see the small check valve, we can see there's some debris in there that's holding that seat open. So it's all, very, very, very important for these very sensitive parts of the system to be maintained and to be cleaned and to be well looked after. Again, thermostatic radiator valves, moving elements, that valve has to modulate, it has to read what the system is doing and adjust to that. If it's full of debris, it's not going to be able to do that. So vitally, vitally important that we give the system the best chance. And again, we spoke about some sort of examples, circulating pumps, it's been sat there, it's been sat stagnant, it's been sat in water that hasn't turned over, it's dirty, it's never going to work, it's never going to be in a good position to give us what we need it to do. We spoke about erosion of internal pipe, we spoke about small solder balls or debris passing through the system. It's going to start to work away, it's going to start to eat away at that internal pipe work. Maybe you wouldn't see that from the outside, but as soon as you cut a cross section into it, you can see the problems it's caused. And again, the more erosion, the more metallic content we put in around the system. Discoloration of a transparent part, sight glasses we spoke about. How anybody could read a flow through that, I don't know. I certainly couldn't read a flow through that, and I've got pretty decent eyesight. So again, we've got to think about ongoing maintenance of the system. We've got to think about people who may need to come and take readings from the system. They've got to be able to look at this equipment and get the readings that they're designed to do. Through that, you're not going to get that. And erosion and clogging of valve seats, vitally, vitally important. The amount of times we see it, we get valves sent back here where our quality team and my technical team will go through and do some inspections, maybe from a job site where there's been issues with valves passing, etc. And we take them apart, and you can see, this is a diaphragm of a valve. Look at the debris that's sitting on there. A valve is never going to work. It's never going to be in a position to operate as it should be designed. So I think it's not until you see pictures like this that you understand that the problems that system debris really can start to cause, and give it a bit of a visual indicator as to why we do what we do. Now, air in systems, is it as harmful a system as physical matter? And I can tell you now, yes, it is. And we are going to focus a lot more on the physical matter when it comes to this presentation. But air is just as dangerous in a closed loop system as what sort of the physical matter is as well. And there's many reasons for that. The efficiency, so we know we're going to get a noisier system. You start introducing air and bubbles into a system, it's going to make a noise. Unfortunately, things like radiators, things like valves, they just become speakers for noise when there's air in the system. So it's vitally important that we take into account all the physical stuff, but also the removal of air to make sure that that's looked after. We get cold spots through the radiator system, so they're not operating as they should do. Air as well can also have a massive impact on corrosion of certainly some of the brass parts and the different components within the pumps, because it almost turns into like a hammer. The air gets through, the air particles start to pop, and they just start to erode away at the equipment. And again, we've got to give it the best chance. So air is just as important to be removed from a system as what the physical matter is, and we will take another look at it in a few more slides time as to why air is so dangerous. But again, it's all about good system maintenance, good system preparation, and making sure that we get everything out of the system, the impurities, whether that be air or physical matter, to allow the system to work as designed and as it should. So what are the effects, the impacts? You know, we've looked at the system sludge, but you know, the magnetite is heavier than water, and it often settles in the radiators and pipework on lower levels, such as ground floors and basements. And if left to build up, it can have a devastating effect on the boiler in the system. Now, if sludge allowed to build up, it can restrict the flow of water through pipework as it begins to block the pipe. And this can be particularly expensive to remediate, and if it blocks the pipe on the heat exchanger, it's even worse. So while new boilers have heat exchange with narrow pipes to allow for better efficiency, it's a double-edged sword because these narrow pipes are more vulnerable to blockages. And it is affected by sludge, and the heat exchanger will most likely be replacing. So this is an actual picture taken with a heat gun, and we can see the center of the radiator is blocked. It's not running sitting at 18 degrees where the rest of it may be sitting at 50 degrees. Now, another reason for this, if we think about how we hydronically balance a system, we really want to slow the water down through the radiator to get the most efficiency from it, to exact all that energy. So, you know, we want the hot water to enter the radiator, but we want it to stay there so we can use all that energy. The heat emitter can take all that heat into the room, and we can send a nice cool return temperature back round, so we're running an efficient system. So although we're trying to slow it down for efficiency, if the system's not clean, it's going to start to allow that sediment, that heavy magnetite, to start to settle in the system. So again, it's important we get it and remove it from the system as quick as possible and as best we can. Now, we had this discussion when we reviewed these slides with my friends across the water, that we drive on the wrong side of the road. It's always up for debate. I understand that. I think we drive on the right side of the road. You think you drive on the right side of the road. But either way, we all have to drive on a side of the road. But what I'm trying to show here is kind of a real life scenario of a clean system versus a dirty system. The road on the left hand side, we can see it's nice and clear, it's empty, it's free flowing. That's how we want our heating system to be. That's how we want our insides of our pipes to look. There's no restrictions, and everything can pass through as easy as possible. Now, add some roadworks into that, add some road cones, add some speed restrictions. All of a sudden, what happens? The cars are starting to queue up. There's blockages. Your journey becomes longer. It becomes slower. And that's exactly what's happening inside the heating system or within the closed system that we're trying to work through now. So imagine that's a piece of pipe, and those road cones are system debris. It could be magnetite, it could be sludge, it could be soldables, it could be anything. But what it's doing, it's adding a restriction. It's causing everything to slow down, everything to run less efficiently. So that's kind of a bit of a visual indicator for me to try and sort of show, you know, what it means in real world. Just imagine roadworks, and that's what a restricted heating system does look like internally. So open vented, the UK way, not so much the UK way now, but we do still have a huge amount of open vented systems in the UK. I personally still have an open vented system at home. My house is probably 30 years old, maybe, yeah, something like that. So, you know, they've been around for some time. They're a tried and tested method. It's a very traditional way of doing it in the olden days. But we'll have a look at what open vented systems are. So what is an open vented system? So open vented systems, they're comprised of a feed and expansion tank, and that's normally located at the highest point of the system, and they work exclusively with heat only, or known as regular boilers. Now, when water is heated, it expands, and the F&E tank will take up the increased volume of water in the system from expansion. As the system cools, the F&E tank feeds water back into the system. So where on a closed loop system or a sealed system, we'd have an expansion vessel. On an open loop system, we have what's called an F&E tank, or a feed and expansion tank. Now, the open vent is a pipe which rises from the heating system to the above the tank, and it hooks over the top. And the open vent pipe is a safety mechanism which will release excess pressure into the system in the event of an overheat fault situation. So where before we use expansion vessels, we use safety relief valves. This is what the open vent system does with the F&E tank. It does it itself. Now, when water is lost in the system, which occurs naturally via evaporation, a supply pipe and float valve will regulate the amount of fresh water back into the system. Very similar to what you see in a toilet system. We have a ball valve or a float valve. So as the system begins to fill up again, the float valve will just adjust itself and it will refill that tank up. Now, this is a traditional setup for a central heating system. Was found in a vast majority of homes until the introduction of modern combi boilers back in the 1980s. So it kind of falls in line with my house being 30 odd years old. I still have an open vented system. Open vented systems are still operating in many homes across the UK today, and in some cases remain a more stable setup. Now, I know Mark, a colleague of mine across the water, asked a question of what is the asked me a question, what is the sort of percentage of open vented versus combination boilers, and the answer is I don't know, because it's a moving target all of the time. Obviously, you know, as people tend to build more houses now, certainly new builds for the next 3 or 4 years are going to have combination boilers in there. Maybe a lot of people have upgraded, as they'd like to think that they've upgraded from an open vented to a combination system. But what the majority, I would safely say there's probably more combination boilers now. But like I say, some people do still see it as a more stable setup, but it's not really something you do as a new install now, is put an open vented system in. You tend to go to maybe a combination boiler. So I don't know what to say, I don't know what the percentage is, but it is still quite high of open vented systems. So brief layout or a brief diagram of what we've got. So we talk about an F&E tank. This is the F&E tank up in the loft. Generally, we put them in the loft space, so mine is in the roof space above my house. The feed and expansion pipe is the one that feeds up to the top, then hooks over into the top, and this is the feed back into the system. So when we are getting the natural evaporation, when we are losing water from the system, that will just top itself back up via the means of a float valve. So heat only, so the boiler's only creating the heat, which then, you know, in turn will go to a cylinder, which go around to radiators, etc., for the hot water. But we do have the F&E tank, which sits up in the roof space. They do take up a lot of space. So I'd probably say that 1/3 of my loft space is taken up by my F&E tank and the pipework that are associated with it as well. The vent pipes, we spoke about the F&E pipe, that's what bends over into the top. So if there is an overpressurization system scenario, that would dump that overpressurized water back into that tank. We've got the ball valve again, so when the water system drops, when it starts to fall below a certain level, it would top itself back up to ensure we've always got water in the system. That's the tank, obviously. Now they should be covered as well. It doesn't show it in that slide, but we should keep them in because you can get a lot of, we've spoken about system debris and stuff. This is the key source of it when it comes to open vented systems, because it's an open part of the system that can fill up. But we'll take a look at the advantages and disadvantages, of which there are probably arguments for both on advantages and disadvantages. Now, so some of the advantages, of open vented systems. So the very few fittings and devices to operate compared to sealed systems, which means a lower maintenance cost. You will know we've got expansion vessels, safety relief valves, filling loops, all the different components that sit within a closed loop system. We don't have that in open vented. Now, where older components such as radiators are present, they are not, that are not to be replaced. Changing to a sealed system can put them under pressure and create leaks. Now, what we mean by that, as traditionally they are a lot older, the systems. You know, we start to put into a closed loop system, it creates a different demand on the system. So it's very important that we, you know, that we consider that when we're making the switch over. And it's much cheaper to swap the boiler and leave all the other components in place. You know, if you were to have a problem. Some of the disadvantages: only use a heat only boiler, and they cannot work with combination boilers. Obviously, there's no need for an open feed tank if you've got a combination boiler. Debris can enter via the system via an F&E tanks, as we've just said. You know, you've got the potential in a loft space, and I'm talking dust, I'm talking dead animals, I'm talking something that your wife might throw up there after Christmas because she doesn't want to store it in the house, falls into your F&E tank. Next thing you know, you've got tinsel going around your radiators, and then they are less efficient. There's greater potential for heat loss through the F&E tank. It's an exposed part of the system. So it is very, very likely that you're going to lose some efficiency and some heat through there. They should again be lagged or have jackets on them. Very few are like that in the UK, unfortunately, anymore. So a few of the advantages and disadvantages of that. So I would give you a little bit of an insight into our open vented systems. So they're not great, but they're tried and they're tested and they work, and some people do prefer them. I don't really have an opinion on it. I say mine is an open vented system. Were I to change it, I probably will go to a combination boiler. But as it stands at the moment, I still stick with open vented. So we'll move on now to types of filtration. We've looked at everything now. So we've looked at what's in the boiler, we've looked at what's in the system, we've looked at what we're trying to remove. So how do we do it? You know, we've put this focus on everything that's bad about it, but what can we do as a manufacturer and what can we do as installers to make sure the system works as best it can? So what are we trying to protect it from? It is a very dirty market. So magnetite, we've spoken about about boiler sludge. We've talked about metallic content. So magnetite is a very important one. Non-metallic substances, again, we spoke about that. We talked about PTFE type. We spoke about the risk from F&E tanks, from debris falling in there. So there is also that non-metallic substance as well. But also air. You know, we've touched on it. Air is a vitally important part of the system to be removed because it is very, very dangerous. So we'll take a look at that as well. So first of all, we'll take a look at magnetite. So how do we remove magnetite from a system? It's really, really, really simple. You use a really strong magnet. And I can't say any more than that. So there we go. Problem solved. End of presentation. We can all go home. Or can we? Because what about the rest of the dirty stuff that we've spoken about? You know, we fit a really strong magnet to a system. Fantastic. We're taking them out of the boiler sludge. But how do we remove the other stuff? Where does the non-metallic content go from? So let's just remember that. We'll park it for now. We're talking about strong magnets. It's going to get rid of the magnetites, but there's a lot of other stuff in the system that needs to come out. So next, the non-metallic substance. So the metal particles have now gone. We've put really strong magnets on the system somewhere. We've taken away all that. So we've got to remove the other junk from the system now. It's really, really simple. Let's just fit a Y pattern strainer. There we go. Problem solved. We can all move on. We can go home. But can we? Because there are problems associated with fitting a Y pattern strainer. So what if that strainer is forgotten about? What if someone's installed it somewhere they think is a great place and they've moved on somewhere else and then no one knows it's been fitted in that area, or they're not very easy to access? So the maintenance guy thinks, you know what, I'm not going to check that basket today because it's difficult. I've got to get behind a wall. I've got to get behind some joints and I can't really do that today. My back's a bit sore, so I'll just leave it. But the basket gets blocked. We can see that's a real life basket taken from a strainer. You imagine the system trying to flow through that. It's not going to happen. It's not going to work. So it's very important that, you know, we've got the strainers in the system, we've got the magnets in the system, but everything's got to be accessible. Everything's got to be able to work, to be able to maintain the system as best we can. So what do we have? Now we're going to start doing some praising of the Caleffi product. So we have various filters that sit within our market, within our range. And these are two options here that I'm going to show you, is what we call the Dirt Mag Pro. The version on the left-hand side is for the US market. The one on the right-hand side is what we use, is what's available for the UK market. So what we're doing here is we're trying to do a bit of everything. So we've spoken out a really strong magnet and we've spoken about putting a Y pattern strainer. But what happens if we bring those two together? We get a system filter. So we can see within here now, we have like a mesh within here now that's going to start to catch a substrate that's non-metallic. So any of those impurities that start to pass through the system, they're going to start to fall down and they're going to capture in the chamber. But more important, what we've also got inside there is a really, really strong magnet, but it's a dry pocket magnet as well. So what happens is that the dirty water enters into the chamber. It's caught by the non-metallic ferrous system, is caught by the initial filter or the gauze. And then we've got a central magnet to catch the metallic content, but it's actually got a dual magnet. It's got two magnets on there. So we've got a center one to catch the bigger parts, and anything else that may still be circling, it's got a potential to pass back into the system. We've got a strap or a clip-on magnet as well. So we're taking a three-pronged attack. We've got two magnets and we've got also a mesh in there to catch those non-metallic parts. And on the UK version, very similar, slightly different the way of the design because of where the pipework enters. But again, we have, you know, the dirty water entering, pushed up into the mesh. That's disturbing the flow. It's slowing the flow rate down. So the heavy particles, the heavy dirty particles in the water, they start to drop into the collection chamber. Again, dual magnet, so very strong magnet through the center, and the clip-on magnet as well. They catch all that metallic content. What we also do have as well is an air vent. So we've spoken about removing the air from the system. We've spoken about making sure, you know, we're getting through the magnetites, the non-metallic mess, and also the air. We can combat all that in one simple system, easy to access, easy to service, something that's generally fitted in and around the boiler area. So, you know, on routine maintenance, we can look after that. And a slightly different one that we have, I know this isn't available in the US market, but something that we have, and it's what we call the Dirt Mag Mini. It's very small, it's very compact, and it's really designed to sit underneath a system boiler. It's clever in the way it can be installed. So we can have it as a straight through filter. So we come in through the bottom, back out through the top. but we can also have it as like an L pattern. So this connection can come down into the center port, the other port fits onto the top. So it's very unique in the way it can be installed, but it works in a very similar way to what the other two do. Again, very strong dry pocket magnet. We've got a high gauze mesh within there as well to catch the small particles, cleans the system, returns it back through. System can work as designed. Very easy to service, very easy to maintain. You know, it's literally a case of isolating the water, removing the magnet, make sure that all the dirty material drops down, drain into a bucket, you reset your system back off again. So again, it's just another way of doing it. It's just how we do it in the UK. It's the Dirt Mag Mini for us. You know, it's a very big set, very nice, very small, very compact, and what people like to see. This scale Dirt Mag, again, another product that's evolving through the market. You know, this one with evolutions. Again, you know, we're taking away here, so we're taking away the dirt within the system, we're taking away the metallic content. We've also now introduced an automatic air vent. So as it's continually going through cleaning the system with the detritus, with the debris from the metallic and the non-metallic, it's automatically venting the air as well. Two types there. The one on the right side is a new one that's just been released into the UK and I think hopefully into the US as well. But again, just different versions, just different ways of removing that as a one-stop shop to make sure that all of that detritus and debris is removed from the system. And finally, complete separation. And what I mean by that is here we're hydraulically separating. We're taking the air out of the system and we're taking away the ferrous particles. So it's a complete form of separation. All in one unit. Again, automatic air venting. We've got the meshes to collect the detritus, and also there's a magnet on there as well. So all different, very different solutions that we have across the Caleffi range, not just in the US but the UK and worldwide, to try and combat some of the problems that we've been speaking about for the last half an hour or so. And then the last little bit from me. Oh, sorry.
Hey, Ed. Yeah, just real quick. I just wanted to mention, this is Cody, just mention too that, you know, we didn't want to tease everybody in the US here with cool products that you guys have over in the UK market and the European markets. We just wanted to show you more than anything what they are capable of doing, what Caleffi is capable of doing. We've got a lot of really interesting products. But I also wanted to ask too, Ed, you know, is it a requirement over in your market to have some type of a debris removal device on your systems? Is it required, or is it just a good idea?
Yeah, so we will touch on this. I think when we talk about BS 7593, which is our water quality standard, that in the revision which was brought out not last year, the year before, I think there is now a requirement for you to fit a system boiler, a system filter to a boiler. So I think a lot of it is more on new installs, but there is now part of the British standard is to fit some form of filtration system on there. And a lot of boiler manufacturers and manufacturers, you know, like us have sort of twigged onto it, because you know, it's very easy for a warranty call to just say system, you know, dirty, poor water quality, no warranty valid. So what they've started doing now is every boiler manufacturer in the UK will sell a boiler with a system filter, and then they'll get a 5 or 10 year warranty to, you know, as long as they fit it to go along with it. So there is some form of requirement now in 7593, which states about having a system filter on there.
That's really interesting to me, Ed, because, you know, over here it's kind of like the Wild West, you know, and you just do whatever you want, and if the budget doesn't allow for it, well, good luck. You know, you're not getting a filter or a separator of any sort. So I think it's really interesting what you guys do.
I mean, there, you say it's a free for all, doesn't mean that anyone does it. It just means it's in the standard. Doesn't mean anybody adheres to it. Let's be honest. But it is, and it is changing the mindset of people now. I will say that.
Sure.
It's a very much a spoken about product now with system filter, so I will say that it is, yeah.
Cool. Thank you.
No problems. So we'll move now. This is the last little bit for me now. We're just going to talk about power flushing. Now, how and what is power flushing? So a power flush is a cleansing process or a cleaning process for your boiler, which removes any dirt, sludge, rust and debris that may have accumulated within your system over time. Now, if these substances are left in your heating system, these can cause blockages or corrosion and ultimately reduce the efficiency of your boiler, and that can even lead to a breakdown. If there's any breakdown engineers on here, I'm sure that's fantastic for you. You're getting the call out. But if it's Mrs. Mary Jones sitting at home on a Sunday evening and the heating goes off, it's not ideal. And again, we spoke before, you know, radiators are a big key part of this, and why we tend to use a power flush system. Some images that you've seen from previous slides as well. So it's about trying to remove the sludge from the system. Now there was the next slide we'll talk through this, but this was something that came from Cody, which I did end up putting back into the presentation or adding to the presentation. That a power flush is an easy way to forcibly remove the sludge or rubbish from your system. And this is done by breaking into the system through either a radiator or the means of such as a fill and flush valve, and pumping water at high velocity around the system to dislodge unwanted rubbish. Now, Cody, I think it was yourself that pointed this out, that you'd seen a video or something of a UK power flush and someone was doing something to the radiator. Now, we suffer so much with poor systems over here that we have to use some form of agitator on the system to break down the metallic content. Because it gets warm and because it gets heavy, it almost becomes like a piece of steel plate. And what we have to do is use a special tool, whether it be attachment to a drill or something different, and it just vibrates very fast and very heavily, and then it goes across the radiator, and it just starts to free up all of that sort of the stuff that's starting to collect in the radiators, and it just allows it to be power flushed all the way through. So there are different means of doing it. Some people do it manually, maybe with a hammer, but there are tools on the market that will allow you to agitate the system. It can be done on certain bits of pipe work as well. But a power flush is just very much about increasing the velocity, increasing the turnover of water through the system. You can add chemicals should you wish into that to do different types of chemical flushing. Maybe you can put some into the system, some form of system cleaner, leave it to work for an hour or two, and then go back and flush that through and remove all the agitated particles that may have gathered. But yes, we do have systems that are that poor quality over here that we have to physically knock the sludge out of the radiator, shall we say, with some form of tools, etc. So very important. You know, a lot of these solutions that we've looked at as we've gone through this presentation are designed to maintain a clean system. It's very difficult to put something like one of our filtration systems to a really old, dirty system and expect it to start working straight away. It's not. It's going to live a lot more maintenance. It's going to need a lot more care. It's going to need a lot more checking. So something like a power flush gives something like the magnet a very good, so the magnetic filters, etc., a very good chance of maintaining, because this is about maintaining systems. We've got to get it clean in the first place, but then we've got to maintain that system cleanliness, and that's what it's designed to do. When it comes into that, so power flushing, and then get some nice, some nice filters on there to maintain the system. And you'll be pleased to know that is my side of the presentation done. I know that you may all still be awake or asleep. I don't know where anybody is at the moment, but I hope
we all set our alarm. We set our alarm, Ed, so we're good.
You've all just drawn eyeballs on the back of your eyelids, but I hope that's
that was really good
into what the problems that we come across. We joked, we do have systems in this country that are so old that we spend probably weeks looking for a connection to get from a 1 3/8" lead pipe onto a piece of 54mm copper or something, because that's sort of the systems that we have in the UK. They are very, very old and not very well designed and not very well maintained, and that's why something like this, I think, is key to put across, that we have to try and look after these systems as best we can.
Well, I just have something to add here on the last one as far as power flushing.
Go back one slide.
Go back one slide there. What I thought was absolutely one of the strangest things, that we talked about this, is that there are companies in the UK that they make their entire living off of power flushing hydronic systems. Yeah. Okay, that's like the companies that just do nothing but drain cleaning as far as plumbing is concerned. That we just don't have that here in the United States or in Canada. I mean, it's just very wild to see. And the other thing that I always mention when I talk about removing debris in hydronic systems is everybody says, I've got a dirty system and I need to put on a magnetic or some type of magnetic separator or a dirt separator device. It's like, that's fantastic. It'll protect your boilers, it'll protect your circulators, it'll be in the mechanical room, but it does not get rid of all the junk that's in there and throughout the systems. And so a dirt separator like that is great, but it's only part of the solution. You need to take it a step further. If there's that much junk in there that's wrecking circulators and everything else, it's going to cause a lot of issues in all other places. And so that's when you need to get out the big jackhammer and hit all the radiators and then sell them new radiators, because you poked holes in every one of them.
And that is one of the problems that we probably didn't really touch on, is that obviously on some older systems, you start to introduce high velocity, high pressure water. Some of those joints can't take it because they're that old and that corroded, that sometimes the sludge is holding it together and keeping it from leaking. So.
Exactly, and we get that on a lot of like steam conversions and stuff like that, where they try to pressurize it, and it's like that ain't gonna happen, But no, that was fantastic. So
yeah, it's very much risk and reward. what reward you're going to get from the risk you're going to put into the system. So that's one thing that I will say, it's risk and reward when it comes to power flushing.
Sure, and we had a couple questions kind of related to that, and actually go back one more time to that last slide. So you addressed the inherent dangers of flushing a system, which is a question that comes up, that you may release enough sludge that you plug something or you have a leak or whatever. The other thing that I think it's important to point out on that bottom left, that when you say power flushing, you're not referring to just the system pump doing that work. This is a separate set of velocity, different pump curve to really get that moving. Do you have a velocity target that you shoot for when you're doing a power flush in feet per second?
I think it's all very much system dependent, system size, system age. But I think generally looking maybe 1.5 meters, 2 meters a second of velocity, something like that, something that's a big increase in what a normal circulator would do. But again, it's down to the system, down to pipe size, and it's down to if you've got 1 radiator, you've got 10 radiators, and everything like that. So again, that's probably why we have companies in the UK that do this, because they would come out, they would do their due diligence, and they would say, and it's the way that they do it is obviously they turn it with a big tank, and it's got an external pump, and they can reverse the flow, so they're almost like it's sludged its way through the system forwards and back, and then all of a sudden they start to dump it out. So it's really impressive. If you see it done properly, it's a really impressive process, but quite scary when you see what comes out down the drain. So
yeah, and I think that Cody was probably just doing the conversion there, but what do we, like 6 feet per second is generally going to be able to carry a little bit more than just that 2 to 4 feet per second or something like that, that may be closer to a design. So we've had some cases where once you get that velocity high enough, you get the glove or the cell phone that fell into some large diameter pipe to show up somewhere else, but that normal system velocity won't necessarily flush and get the debris all the way around from the radiator or something like that.
Yeah,
so
I think as well, the size of the system, you're going to have an index point, which is going to be your furthest point, where you still need to make sure you've got enough velocity that it's going to get all the way around and bring it back out around the system. So yeah, it's an art, it's a science, I'll give it that much.
Yeah, and then there was a question about up to like 3-inch systems, and that's probably not a pump that you're going to carry on your backpack into the job site. That might be a little bit bigger piece of equipment
I think
to be able to flush that well.
So the working different ways. I'm from a larger system background, and we had this discussion earlier when I spoke about this to somebody before, that larger systems are generally designed with all this in mind prior to them being put together. Maybe not some of the older ones, but certainly when I used to install big systems, we used to have a lot of dirt and air separators, a lot of filtration systems, a lot of wide pattern strainers. It's already designed into the system. So maybe a power flush it's probably not possible on some systems because they're so big, but they've certainly got different ways that they do it, through the system. So it's sort of engineered into it at the start. Yeah,
there was a story that that we heard from like a geothermal loop field, that it was a truck came. It was like the whole back of a tractor trailer that you need to flush, a big industrial sized geosystem like that. So a little different than the system pump.
Absolutely, yeah, definitely.
Another thing that I wanted to bring up too, and you touched on it, I just think it's really important to bring it up again, is that if you don't have a dedicated dirt removal device in your system, there's still going to be a dirt removal device in your system. Okay, it's just usually not what you want it to be. It's going to be your radiator, your boiler, somewhere where you don't want it. Circulator. Yes, the dirt's going to end up going somewhere, and it's going to stay there. And it's usually those areas of low velocity. And I always preach on, harp on velocity. The areas of low velocity is where that stuff's going to want to settle. So the bottom of a cast iron boiler, or the bottom of these radiators where the velocity is much lower, is going to make a big difference. And so again, remember, there's always a dirt removal device in your system, always. And I always harp on the fact too that it's not just old systems that need it. It's brand new systems too. Whether it be solder, BB's, flux tape, whatever the case may be. I mean, they're all going to need it. And so don't discount it, the fact that it's brand new. I don't need it. The pipes are all clean. Like I've seen plenty of dirty pipes come off of distributor trucks. There's there's no mercy when it comes to dirt. So
yeah, no, I absolutely agree. No, I do agree, and that's, you know, that will probably move us on to sort of 7593, where they now state that, you know, you do have to put system filters, you do have to maintain chemical levels if you're keeping the chemicals in there. There is a universal standard now for checking the solidity of the system and how much the, you know, inhibitors in there, and then it's every 12 months or every 5 years you have to flush it, drain it, retrote it, and all that sort of stuff. So we are sort of getting on top of it, I think, and we are starting to take it a lot more seriously, because I think technology is increasing as well. You know, the technology, the boilers are getting more, and, you know, they need clean systems to work. So, you know, that's sort of what 7593 is starting to bring into the UK market, certainly.
And then I got a little bit of information gathered about the VDI standard too. So like I said there, it translates to the Society of German Engineers, and their code developers over there, like IAPMO would be in the States, but they have specific numbers for, you know, parts per million of dissolved oxygen, 0.1 total dissolved solid numbers, the operating pH they like to see between 8.2 and 10. So that's a pretty specific standard that's been developed over a lot of years, and was one of the things that the group, including our own, Bob Rohr was on this IAPMO committee that developed this H1001.1 hydronic water quality standard, which actually is available for purchase as of last Friday. So this is kind of breaking news for this webinar, which is helpful. So I'll actually hit send. I'm going to put the link to be able to purchase that document on the IAPMO website in the chat there if anybody wants to take a look. But it is helpful because it breaks down systems with or without additives, has differentiation for different system sizes. So are we talking, you know, a small residential boiler? Are we talking, you know, a big heating plant for you know, maybe multi-residential or a commercial building or something like that? And then it does actually have, which is helpful, some numeric limits for aluminum, chlorides, copper, iron, and it has now been submitted to ANSI for public review. So if you're passionate about this, you're obviously attending this webinar, there will be a public comment period that you can put in your 2 cents to say, hey, you guys should really specify that with this, you need to measure this, and this affects this, or that type of thing. So this is going to be kind of a living document that you can participate in. And then hopefully, I think that the intent is that maybe equipment manufacturers might pick up on this and say, hey, listen, in order to maintain your warranty, stay within the IAPMO H1001.1 boundaries, and you're in good shape. Because currently it is up in the air, like we talked about before, if an equipment manufacturer is going to stand behind a warranty if it's a water quality issue, but you may not get a very specific number for parts per million of aluminum or something like that that can make a difference. So keep an eye on that document, available to buy now from IAPMO, and yeah, definitely something that we're slowly getting more specific with what we mean by good water quality in the States. And it's helpful to have the VDI and the British standard to look at for some guidance there with systems that have been operating with those conditions for a long time.
Yeah, just on the VDI one, I actually did a podcast. It's, if you go to the Altechnic YouTube page, there's a podcast that I did with an engineer who only installs VDI systems in the UK now. He's trying to bring it over. So it's really interesting actually just to listen to the different ways of doing it using the VDI process. So I wasn't trying to do a free plug there. I just remembered that I've done a podcast on VDI. So if anybody is interested, just head over to the Altechnic page and there is some information there on VDI. So
great.
Okay. Well, look at that. Look like I've just come back off holiday on that.
Yeah, you've even got the same branding there with the sweatshirt and everything. So
yeah. Keep it consistent. But yeah, we can share. I think we've openly done that. I think across this, and I think there is a lot we can share. I think there's a lot of commonality between what we do. There's a lot of difference as well. You know, I think that's open and obvious to see. And I think that's just purely the some of the poor installs that maybe we both countries come across. You know, the poor system design, poor system maintenance, but I think together we're all slowly starting to get on top of it and move the industry forward. I think when it comes to systems and system design and system maintenance.
Yeah, and it's not going anywhere. This is going to be something that is around forever, even like we mentioned with new systems. So yeah, what else were you going to add there, Cody?
Yeah, I needed to find the unmute button, which is
Never
easy to hide, you know. But you know, I was just going to mention, you know, you guys over in the European markets, you know, your fuel costs, your energy costs are so much higher, and there's so much more at stake for these dirty systems and for these dirty boilers and everything else. And it's, you know, seemingly in the States, you know, we're all kind of, you know, c'est la vie, you know, it's the cost of doing business. You know, we've got this dirty system that isn't as efficient as it could or should be, you know, and until there's a big incentive for a lot of this, or a requirement in a lot of cases, you know, it's tough to justify for some. But you know, in order to give your customer the best shot at having a reliable system, and I always tell people, you know, these customers are spending, you know, $5, $8, $10, $20,000 on these pieces of equipment or systems in general. You know, their expectations are very high, and the fact is they want the system to last a long time. It's an investment, and the best way to do that is to protect it. And even if your fuel costs are low, you know, I mean, it's just going to add to the longevity of a system to be able to protect it and keep it running for as long as you can, as opposed to just saying, you know, that was an extra $300 that I didn't need to spend. You know, let's just nix it. You know,
forward planning and forward thinking, isn't it? And not look at the bottom line here of the cost, but look at the life cycle cost of the system and the product, which I think is very important as well. So,
and I think we even brought up in conversation, Ed, too, you know, the fact is I think you said it, Max, how long do people live in a house here in the United States?
Yeah.
I think you said like 7 years or something.
7 years on average or something like that, yeah.
And Ed was saying like just the opposite.
60 years, my nan's lived in the same house, you know.
Yeah, I mean, people don't think about investing when they're like, oh, I'm just going to leave in 7 years, you know, like, whereas in Ed's world, it's like his grandma's been in the same house for 60 years, for crying out loud, you know, like she wants to make sure that that system works and works well, and you know, they want to do things right, you know, and in a lot of cases. And
it's a completely different mindset, I think, and one I think that we'll all come around to eventually. But yeah, Max,
Perfect.
Back over to you if you've got any more to add on. The slides that left, but...
Yeah, I'll just kind of bring it home here. So here's our technical support team. We're great at addressing application specific stuff too. So if you have a job site that's driving you crazy, or if you're an engineer and you come across something that you have to fix, we're happy to help with that, and sizing and applications and that type of support. So give us a call or send us an email. All right, we've got a podcast with two of our tech support guys, Dan and Greg, the Ask Caleffi podcast. So we've got new episodes up there. That's a great one if you're driving to work or something like that, like Ed does in the UK. Just opens us up to a little bit different audience, a different time of day potentially. So check out the Ask Caleffi podcast. And then Cody does the series 5 Things You Need to Know. This is on YouTube. This is my favorite thing to point people at the wholesale counter to, or people in a contractor shop who may not have an hour to sit down and listen to this webinar, but they need in 5 minutes 5 things to know about pressure reducing valves or something like that. This is a great series for that group, so check that out. Okay, and then follow us on social media. If you've got cool job sites and you want to brag about them, we'd love to see those on Instagram, and we'll say something cool about your project there. So tag us there and follow us. And that's it. So thanks again to Ed. We're happy to have you. Thanks for staying late. Have fun on your holiday. And
I will certainly try. Thank you for having me. It's been enjoyable. So, and thank you everybody for sitting around and listening to me. So I do really appreciate that.
Thanks a lot, Ed.
Sounds good. Thanks, Ed.
No problem. Cheers all.
Everybody.
Thank you.
See you guys.